Welcome everybody to Unit 4.7. This is our last trig identity lesson. This is double and half angle identities. So using the sum identities, we can change from x plus y, which would be two different angles, to x plus x. So now we're creating a double angle. And when we change that in the expanded form to all of our angles being x, we now have two terms of like terms that we can combine. And so sine of 2x would equal 2 sine x cosine x. So that gives us a new identity. Similarly, for cosine and tangent, okay, we're going to do the same thing where we swap out the addition of two different angles for the addition of the same angle. And then we end up with some like terms that we can add together in the numerator here, and in the denominator we can multiply. So that's our tangent double angle identity. And then last but not least, we take the sum of cosine and we end up originally, okay, with cosine squared minus sine squared. But we know that cosine squared and sine squared are a big part of the Pythagorean identities. So cosine 2 theta or cosine 2x, okay, the double angle here, you actually have three different forms depending on how you swap out that Pythagorean identity of cosine squared plus sine squared equals 1. So for a double angle of cosine, you could use any one of these three identities. It just depends on the situation and perhaps what values you're given to work with. Okay, so the first identity, you would potentially, in order to evaluate that, you would potentially have to find the sine and the cosine, but maybe if you were given the sine, you would want to use that middle identity so that you didn't have to do any additional work. Okay, and we'll see that coming up in some of our examples. Okay, we also have our half angle identities. Okay, these are a little bit more complicated derivations, so these are just the identities here, okay? And you notice that these all have plus or minus because they're square roots. So we actually have to determine if it is a positive or a negative value depending on where the original angle falls on the coordinate plane. So we're going to use all students take calculus, okay, in determining that. And when we refer to the original angle, theta over 2, or x over 2, is the original angle. Okay, so we want to keep that in mind, that theta over 2 is actually the original angle. All right, so the first type of problem we're going to do is just straight up evaluating. So just like we did with sum and difference, we have to use the angle values that are on our trig chart. Okay, so in order to come up with 15 degrees using half or double, I could take theta equals 30, and if I took half of that, having a hard time here today. All right, theta equals 30. So if I did a half angle, theta over 2 would be 15, okay, because I would be doing 30 over 2. So I'm going to use 30 as my theta here, and that would give me sine of 15. So I'm going to take my half angle for sine, okay, using my identities. plus or minus all right, so we're going to save the plus or minus until the end, and we're going to evaluate what's underneath the square root. So I can use my chart to find cosine of 30. Okay, so cosine of 30 equals root 3 over 2. Okay, and now I need to simplify what's underneath my square root there. So I'm going to make a common denominator. I'm going to put this over 1, multiply top and bottom by 2. So I'm looking at 2 minus root 3 all over 2. Okay, that's the numerator. And then I have this denominator of 2. Okay, and now I'm going to multiply by the reciprocal. Again, this is all still underneath the radical. So 2 minus root 3 over 2, multiply by the reciprocal, really multiplying by 1/2. Okay, we multiply fractions across the top and across the bottom. So I can actually square root the bottom, so that's a perfect square. So that'll come out as a 2, and then the top we're going to leave in, and we're just going to leave that radical inside a radical. We're just going to let that happen. Okay, but now we need to figure out, well, is this positive or negative? So the original angle here is 15 degrees. That's theta over 2. That's the original. So 15 degrees is in quadrant 1. And using all students take calculus, all of our trig identities are positive in quadrant 1. So we're going to take the positive of this option. Okay, and that's your exact value. So we'll get rid of the minus. We're going to leave it exactly as it is, radical inside a radical and all. Okay, so that's just a very routine, just evaluating an angle using double or half. Okay, it gives us a little bit more flexibility than the values that are in our trig chart, because 15 doesn't show up because 15 degrees is not part of a special right triangle. All right, now we're going to do some proving. Okay, so we're going to use the double angle formula. Okay, it's being specified here, to prove that cosine of 60 equals 1/2. Okay, well obviously we can look this up in our chart and we can see that, but we're going to prove it using the identity. So we're going to work on the left side because I can't use my identity on 1/2. Okay, using double angle, what value of theta would I have to double in order to arrive at 60? Has to equal 60. Okay, I would need to use theta equals 30. Okay, so my double angle for cosine, remember we have 3 of these. Okay, I'm going to use I'm not going to use cosine squared minus sine squared because why would I want to introduce 2 different trig values? Okay, so I'm going to use 1 minus 2 sine squared x. Okay, so if this is cosine of 2 times 30, okay, and the identity that we're using, 1 minus 2 sine squared theta. So the left side here is 1 minus 2 sine squared of 30, okay? And that's supposed to come out to be 1/2. So now I want to find out, well, what is the sine of 30? Okay, and sine of 30 is 1/2. And in order to get sine squared, we just square that 1/2. Okay, so now all that's left to do is evaluate the left side. Okay, so 1/2 squared gets me 0.25. Multiply by 2, that gets me 0.5. So this is 1 minus 0.5 equals 1/2. So 1/2 equals 1/2. So we just proved. Okay, now you could have used sine squared minus cosine squared. You could have used 2 cosine squared minus 1. It does not matter. I was just trying to eliminate the need to evaluate 2 different trig functions. All right, so these are the more complicated problems. Okay, they're asking you to find the exact value of sine 2 theta. Okay, so the double angle of sine. And they're giving you information about theta, what theta to use. So I don't actually know what angle we're evaluating here, but I don't need it because they're giving me the sine, which means that I can build a triangle. Okay, and not only are they giving me the sine, they're also telling me what quadrant I should be in. Because remember, if I have a positive sign here, I could be in the first or the second. Okay, and I could have 2 different angles, but they're narrowing it down, okay, and putting it in quadrant 1. So what I'm going to do first is build a triangle in quadrant 1. Okay, I'm using quadrant 1 because it says 0 to 90 here. Okay, so this is my theta, and sine is opposite over hypotenuse. So the opposite side of my triangle here is 2, and my hypotenuse is 3. So I'm going to go ahead and Pythagorean theorem here to complete the rest of my triangle, which means that this bottom side is square root of 5. All right, so I have a complete triangle now. So now find sine of 2 theta. I'm going to use my identity. So sine of 2 theta is 2 sine theta cosine theta. Okay, so I need to evaluate sine of theta and cosine of theta. But again, I don't know the angle. So how am I supposed to use my chart? Doesn't matter what the angle is. We have the triangle. So we're going back to old school SOHCAHTOA here. So sine of that triangle, opposite over hypotenuse, they actually already gave me that in the problem. I could just use that again. And now I need the cosine, which is adjacent over hypotenuse. So root 5 over 3. And now I'm just going to evaluate that. Anytime that you have a radical, though, you're going to need to sort of evaluate that part by hand because you want to keep it as a radical so that it's exact. All right, so this 2 out front, I'm going to put over 1. So multiply across the bottom, I get 9. And across the top, I'm going to get 4 root 5. Okay, 4 and 9 aren't going to simplify. This is my exact answer. That's what I'm looking for. That would be the value for sine 2 theta, whatever theta happens to be. Let's do another one of these. Okay, so now I'm being asked to find the half angle, cosine of theta over 2. Okay, I'm being provided some information about the sine of the angle, and then again, they're telling me which quadrant. They have to tell you which quadrant, and they have to give you some values of sine, cosine, tangent so that you can build a triangle. Okay, so I'm going to start by building my triangle. So 180 to 270 is the third quadrant. Okay, and they're giving me sine, giving me the sine value. So this is opposite over hypotenuse. Now the hypotenuse can never be negative, so just make sure that you're placing the negative on the appropriate side. Just because it's in the top of this fraction doesn't necessarily mean that the top number is always going to be the negative one. Okay, and then I'm going to solve for the rest of my triangle. That side is -3 as well. Think about what quadrant you're in. Make sure that it's the appropriate sign. S-I-G-N, not trig sign. All right, so now we're doing the half angle for cosine. So my identity for that, plus or minus 1 plus cosine theta over 2. Okay, so I'm going to use the triangle that I created to evaluate for cosine. And remember, I'm going to choose my plus or minus at the end here. Okay, so cosine of this angle adjacent over hypotenuse is -3 over 5. Okay, so I'm just going to use the calculator to evaluate inside the square root here. Okay, since there's no square roots, there's no radicals to deal with, I can do it all that way. But I do want to keep my answer as a fraction, so I end up with 1/5. Okay, and square rooting a fraction, you can square root the top and square root the bottom. Okay, so square root of 1 is 1. Can't do square root of 5. And I also now need to rationalize that, because I'm not going to leave a radical in the bottom. Okay, so that's my final value, square root of 5 over 5. And now I have to determine if it's plus or minus. Okay, so theta over 2 is the original angle, and I need to know what quadrant that's in. Well, the only quadrant information that they gave me is where theta is. They said theta is in between 180 and 270. And I want to know, well, where is theta over 2? So I can cut this information in half, and that'll tell me where theta over 2 is. It's between 90 and 135. So from 90 to 135 is quadrant 2. And what trig function did we do here? We did cosine. We found the cosine of theta over 2. So all students take calculus. Cosine is negative in quadrant 2. That's the sign we're going to choose. So our final answer should be -√5 over 5. Okay, so again, we're taking the quadrant information for theta, but the original angle is theta over 2. And that's where we have to figure out what quadrant that angle is in. We don't care where theta is, because we're evaluating theta over 2. I have to know what quadrant is that in. Just like we did with sine of 15 degrees in the very first example. We figured out where was 15. 15 was in the first quadrant. That's how we picked positive or negative. Okay, we'll do another one of these. All right, so now we're looking to do the half angle of sine. Okay, and they're telling me that my angle is in between, my theta is in between 90 and 180. So that's quadrant 2. Okay, and based on this information that sine of theta equals 2 over 3, I'm going to build my triangle. Okay, my my missing side has to be minus square root of 5, because think that's the negative x-axis over there. All right, so now I'm solving for sine of theta over 2. So using my trig identity, it's plus or minus 1 minus cosine theta over 2. Okay. So I need to know what is the cosine of this triangle. Adjacent over hypotenuse, negative root 5 over 3. Okay, and now I'm going to clean this up. So make a common denominator on the top. So I'm going to multiply by 3. Minus the negative, this becomes plus. Okay, and now I'm going to end up multiplying by the reciprocal of the denominator. So it's going to be times 1/2. It's always going to be times 1/2 for these. Okay. All right, so the denominator is not going to simplify like it did in one of our previous examples, and I'm not going to have you rationalize with the square root of 6 top and bottom when the numerator of this problem already has a square root under it. So long story longer, we're going to leave our answer just like that, okay? But we do have to figure out if it's positive or negative, okay? So theta over 2 is the original angle. And I only know where theta is. So theta is in between 90 and 180. So where is theta over 2? Okay, theta over 2 is going to be in between 45 and 90. So where is 45 to 90? That's quadrant 1. All students take calculus. So in quadrant 1, everything is positive. We're finding the sign here just for prosperity to know, okay? But everything is positive. So we're going to take the plus of this whole mess, okay? And that is going to be our final answer. All right, so those first type of routine questions where we're just evaluating using a half or double angle, those are pretty simple. Even the proving ones are not so terrible. Okay, there's a lot more actually evaluating trig functions in this because you have to use 2 different angles. You saw that in sum and difference. Okay, but these last 3 types of problems are definitely much more complicated. So this is really what we're going to want to focus on, okay, in our note taking and then in our practice in class. All right, so those are all the types of problems we're going to look at right now. Please just make sure that your notes are complete. Very, very important because this is a difficult topic. Write down any questions that you may have so that we can go over those in class together. All right, that's it for this time. Thanks so much for watching, guys.